First, let's look at the statement, the United States is above Mexico. Well, we know we have a subject, the United States. We have our verb, which is, which is meaning equal to, and it is above Mexico. In the same way, Mexico is our subject, is our verb, and above the United States. Now, both of these sentences show proper grammar. However, we don't necessarily know that these are true. The United States is above Mexico. Well, we know this has to be true because if you look in the map, North America is laid out as Canada, the United States, and Mexico. So this sentence is true. But Mexico is above the United States. Based on what I just said before, Canada, United States, Mexico, Mexico is under the United States. So as much as this statement is grammatically correct, it is not a true statement. It's false. These language principles apply to math in the exact same way. What we have to start doing is looking at mathematics and mathematical expressions like a language. First, we need a subject, in this case 2 plus 3. We need our verb, which is an equal sign. And we need to rename our subject. Here we have a numerical expression 2 plus 3. We have a different numerical expression 4 plus 1, but they are both equal numerical expressions. Therefore, they are true. In the same way, we can have a subject. We can have a verb, which is our equal sign, and we can have a different numerical subject. But this also doesn't guarantee that it's true. Because when you figure them out, 2 plus 5, and you solve 4 plus 4 is 8, this is not a true statement. One thing you have to know is that numerically equivalent statements aren't always going to look equivalent at the start. Take this example, 1/3 and 7/9. Well, one is in fractional form, another one is in decimal form. So they can't be equal. Actually, they can. Because if you added these together, you would get 1.1111. If you add these together, it's going to get 1.1111. So actually, these two statements are equal and true, despite the fact that they look really different. This expression has it in fractional form, and this side of the equation has it in fractional form. However, we know that this is not true because 1/4 plus 1/3, they do not have similar denominators. We would have to change it to a common denominator, which is 12. Times this by 3 over 3 to get 12, which would be 3/12. Times this by 4. Multiply this by 4. This actually equals 7/12, which is not the same answer as 2/7, which means that this statement is false. Another example of certain equations looking the same but not actually being equal is with exponents. Here we have 7 plus 9 in parentheses being squared. Here we have 7 squared plus 9 squared. Now they really look similar, they have the same numbers, the same exponents. However, I'm not exactly sure if these are equal. Is this statement true or is it false? I'm really not sure. The best way to handle this is to go into your calculator or do the math yourself and solve. So we know 7 squared is 49. 9 squared is 81. 49 plus 81 is 130. On this side of the equation, 7 plus 9 can be added because it's in the parentheses. And based on PEMDAS, we would do that before we distribute the exponent. So 7 plus 9 is 16. 16 squared is 256. Despite these equations looking equal, they do not equal each other, and it is a false statement.